Hi, welcome to today's lesson. This is Ma'am Clarence, and we will now discuss Chapter 1, Lesson 3, or that is Evaluating Limits Using Substitution Method. So our goal for today are 1. Compute the limits of algebraic, exponential, and trigonometric functions using substitution, and identify the limits of sine x over x, 1 minus cosine x over x, and e raised to x over x. Now, when we are evaluating limits using substitution, the premise is that if f of c exists, then the limit of f of x as x approaches c is equal to f of c. That means when we get the limit of f of x as x approaches c using substitution method, what we do is we simply substitute c to x and find the value. We have here some examples. 1. Find the limit of x plus 2 as x approaches 5. Again, using the substitution method, we will substitute x with the value of c. We have the limit of x plus 2 as x approaches 5. So, we will substitute x here with 5. So, that would be 5 plus 2. We simplify, that will be 7. Therefore, using the substitution method, the limit of x plus 2 as x approaches 5 is 7. So, in the substitution method, you don't have to use the limit laws anymore. Instead, you directly substitute the value of c to x. Another example, we will find the limit of x minus 3 as x approaches negative 2. Again, we will substitute negative 2 to x. So that would be negative 2 minus 3. Simplify, that would be negative 5. Therefore, the limit of x minus 3 as x approaches negative 2 is negative 5. Next, we will find the limit of 4x plus 7 as x approaches 1. Again, we substitute c to our x variable. That is, we will find the limit of 4x plus 7 by substituting x with 1. So that would be 4 times 1 plus 7. 4 times 1 is 4 plus 7, that would be 11. So the limit of 4x plus 7 as x approaches 1 is 11. Next, we will find the limit of x squared plus 5x plus 1 as x approaches 2. So, again, we substitute 2 to all the x variables in the given function. That would be 2 squared plus 5x, so that would be 5 times 2 plus 1. 2 squared is 4 plus 5 times 2, that's 10, plus 1. Now we simplify this expression. 4 plus 10 plus 1, that would give us 15. So the limit of x squared plus 5x plus 1 as x approaches 2 is equal to 15. Next example, we have to find the limit of 8 over x as x approaches negative 4. Again, we substitute x with the value of c, that is negative 4. So we'll have 8 over negative 4, or that's 8 divided by 4. 8 divided by 4 is negative 2. Therefore, the limit of 8 over x as x approaches negative 4 is negative 2. At times, when we directly substitute the value of x with c in a rational function to solve for the limit, both the numerator and denominator becomes 0. In cases like this, we will use the factoring method. Here's an example. So we will find the limit of x over x squared plus 2x as x approaches 0. So when we directly substitute 0 to our given function, that will become 0 over 0 squared plus 2 times 0. So the answer will be 0 over 0. Now, 0 over 0 is also termed as indeterminate. So when we get 0 over 0 as an answer when looking for limits, that should not be our final answer. Now, to get the final answer, we have to bypass the indeterminate form or the 0 over 0, factoring and simplifying the function. So we have limit x over x plus x as x approaches 0. This rational function. Now, x could not be factored out anymore, so that would still be x. X squared and 2x have a common factor, which is x. So we take out x as the common factor. X squared divided by x will be x. 2x divided by x will be 2. To check if you got the correct factor, we can multiply. X times x is x squared. X times 2 is 2x. Therefore, x squared plus 2x could be factored out as x times x plus 2. Now, take note we have a common factor in our numerator and denominator, that is x. So we cancel out x in the numerator and x in the denominator. This could be simplified as the limit of 1 over x plus 2. 1 because we have canceled out x here and there is no other remaining variable in our numerator, so we put 1. And we canceled out x in the denominator, and what is left here is the factor x plus 2. So we have limit of 1 over x plus 2 as x approaches 0. So we will now use this new rational function or the simplified rational function to solve for the limit. So again, we substitute 0 to our given function. So that will be 1 over 0 plus 2, or that is 1 over 2 or 1/2. So you could also answer in decimal form, that is 0.5 or 5/10. Let's have another example of this situation. So we have, in this example, okay, when we substitute -4 to the given function, what we get is -4 squared minus 16 all over -4 plus 4. -4 squared is 16 minus 16 over -4 plus 4. 16 minus 16 is 0. -4 plus 4 is also 0, which gives us the answer 0 over 0, or again, we call this the indeterminate form. Again, since we get the indeterminate form, we have to bypass it by factoring and simplifying the function x squared minus 16 over x plus 4. Again, we find the factors of x squared minus 16 over x plus 4. So x squared minus 16 could be factored out as x minus 4 times x plus 4. If you want to know why these are the factors, you can go and visit a video on special products and factoring. So again, x squared minus 16 could be factored out as x minus 4 times x plus 4 all over x minus 4. So the expression now is limit of x minus 4 times x plus 4 all over x plus 4. as x approaches -4. Now we have a common factor of x plus 4, so we will cancel that out. So cancel x plus 4 in the numerator, and we also cancel it out in our denominator. Now, we have x minus 4 in our numerator and 1 in the denominator. So x minus 4 over 1 is just the same as x minus 4. So our new function is now limit of x minus 4 as x approaches -4. So we now substitute -4 to x, that would be -4, minus 4, that will give us -8. So the limit of this function is -8. Let's have one last example for situations like this. So we have the limit of x squared minus 3x over x squared minus 9 as x approaches 3. So, again, if we use the direct substitution method, this will be 3 squared minus 3 times 3 all over 3 squared minus 9. So this will give you 9 minus 9 over 9 minus 9, or that's 0 over 0. Again, this is what we call the indeterminate form. Now, to bypass the indeterminate form, we have to use factoring and we have to simplify the function. So, the limit of x squared minus 3x over x squared minus 9 as x approaches 3 could be expressed as limit of x times x minus 3 over x minus 3 times x plus 3. So, x squared minus 3x could be factored out as x times x minus 3 because x squared and 3x have a common factor of x. So we take out the common factor x and we divide each term by x. So x squared divided by x, that is x, minus 3x divided by x is 3. Again, if you want to check if you got the correct factors, we multiply. X times x, that's x squared, minus x times 3, that's 3x. Next, in the denominator, x squared minus 9 could be factored out as x minus 3 times x plus 3. Again, if you want it to be clearer to you, or if you want to review how does this factoring happen, you can visit a video that specializes in special products and factoring. So, looking at our new expression, we have x minus 3 in both the numerator and denominator. So we cancel out x minus 3 in the numerator and in the denominator. So what is left now of our expression is the limit of x over x plus 3 as x approaches 3. Now we will now use this function and substitute 3 in all of the x variables. So that will be 3 over 3 plus 3, or that is 3 over 6. 3 over 6 could be further simplified as 1/2 or 0.5. Next, we can also use the substitution method in exponential functions. We have an example, limit of 2 raised to x as x approaches 1. So again, using the direct substitution method, we will substitute the x variable with the value of c, or in this example, that is 1. So 2 raised to x will become 2 raised to 1. 2 raised to 1 when simplified is 2. Therefore, the limit of 2 raised to x as x approaches 1 is 2. Next, example, we have the limit of 3 raised to x plus 1 as x approaches negative 1. Substitute negative 1 to x, we get 3 raised to negative 1 plus 1, or that is 3 raised to 0. Remember in the laws of exponents that any number or variable raised to the exponent 0 is equal to 1. So 3 raised to 0 is equal to 1. Therefore, the limit of 3 raised to x plus 1 as x approaches negative 1 is 1. Next, we have the limit of 4 raised to x minus 2 as x approaches 5. So, substitute x with 5, that is 4 raised to 5 minus 2. 4 raised to 5 minus 2 when simplified is 4 raised to 3, or that is 64. That is 4 times 4 times 4. Therefore, the limit of 4 raised to x minus 2 as x approaches 5 is 64. Next example, we have the limit of 2 raised to 2x minus 1 as x approaches 2. So again, we substitute x with the value of our c, that is 2. So that's 2 raised to 2 times 2 minus 1. So that's 2 raised to 4 minus 1, or 2 cubed. 2 cubed is equal to 8. So the limit of 2 raised to 2x minus 1 as x approaches 2 is 8. Next, we have the limit of 2 raised to x minus 7 as x approaches 4. So we substitute x with 4. That would give us 2 raised to 4 minus 7, or that is 2 raised to negative 3. So, using the laws of exponents, 2 raised to negative 3 is 1 over 8. Next, we have the limit of 4 raised to negative x plus 5 as x approaches 7. Again, we substitute x with 7. So that's 4 raised to negative 7 plus 5, or that is 4 raised to negative 2. Again, using the laws of exponents, 4 raised to negative 2 is just the same as 1 over 4 squared, or that is 1 over 16. Here's a fact. For all x in the domain of y is equal to e raised to x over x, take note that the limit of e raised to x over x as x approaches 0 is 1. Now let us proceed to the trigonometric functions sine and cosine. So, sine and cosine are called sinusoidal trigonometric functions. So they are considered as the most fundamental of all the trigonometric functions because all other functions can be expressed in terms of these two functions, or all other functions could be expressed in terms of sine and cosine. So because y equals sine x and y equals cosine x are continuous functions, which means they are defined for any real number x, then the limit as x approaches a certain number may be evaluated using direct substitution. In symbols, we have the limit of sine x as x approaches c is equal to sine c, and the limit of cosine x as x approaches c is equal to cosine c. So we have here some examples. Take note, you may use your calculator for the trigonometric functions. Don't forget to set your calculator in radian mode. Okay, so first example, we have the limit of sine x as x approaches pi over 2. Again, we substitute x with c, that is pi over 2. So this will become sine pi over 2. Using your calculator, sine pi over 2 will give you 1. Again, don't forget to set your calculator to radian mode. or else you will get a different answer for these examples. Next, we have the limit of sine x as x approaches pi over 4. So that will give you sine pi over 4. And sine pi over 4 is equal to 0.71 or 71 hundredths. Next example, we have the limit of cosine x as x approaches pi over 6. So, again, we substitute pi over 6 to our variable x. So that will be cosine pi over 6, or that will give you 0.87 or 87 hundredths. And the last example, we have the limit of cosine x as x approaches pi. So that will give you cosine pi, or that is equal to -1. Now, here is a fact. For all x in the domain of the functions y equals sine x over x and y equals cosine x over x, take note, the limit of sine x over x as x approaches 0 is 1, and the limit of 1 minus cosine x over x as x approaches 0 is 0. Again, do not forget to set your calculator to radian mode. So that's the end of our lesson for today. Bye!